Hey guys, today's video is about model evaluation. We've discussed the concepts of training sets, validation sets, and testing sets. Today we are going to talk about cross-validation. To recap, training sets is used to construct a model by adjusting the internal parameters. Validation sets is used to evaluate the model's performance and tune the hyperparameters. Testing sets is used to measure the model's final performance. One important thing is that training sets and validation sets are used in the training phase, but testing sets is used in the evaluation phase because it can offer an unbiased evaluation of model performance. Alright, let's look at cross-validation. In case you will be confused, I want to be clear first. Validation sets is not involved in the process of cross-validation. To illustrate, cross-validation is a resampling procedure used to assess how a model will generalize to an unseen dataset. In other words, cross-validation is used to evaluate the model's final performance, so it's like testing sets, but cross-validation provides a more reliable way to evaluate the model. In fact, the resampling procedure makes cross-validation reliable, and we'll introduce 4 popular cross-validation methods: k-fold, stratified k-fold, leave p out, and leave 1 out. The most common technique is k-fold cross-validation. First, we partition the whole dataset into k parts with roughly equal size, and each part is called a fold, which is why this method is called k-fold cross-validation. For example, we assign k as 4. So this dataset is randomly partitioned into 4 parts. Second, we use one fold as testing set, and the remaining folds as training set. This procedure is just like the normal evaluation process. The k-1 folds are used to train the model, and the model's performance is evaluated on one fold, which is testing set. And the evaluation measure can be accuracy, recall, precision, or anything you like. The important thing here is that the validation set is not involved because we only look at one and only one model. That is, we don't have to tune the hyperparameters, so validation set is not required. If you have multiple models, you can split the training set into 2 smaller subsets, one for training, another for validation. But that's the topic for another day. We'll focus on cross-validation of one model's performance today. Okay, the third step is that we repeat the step 2 k times and use a different fold as the testing set each time. In the example, k equals to 4, so the model evaluation is repeated 4 times. The orange fold is the testing set, and each set is used as the testing set once. In other words, each fold has acted as the unseen data, and we calculate the accuracy 4 times. Last, the final accuracy of this model is the average of the accuracies of all model evaluation. Basically, you just sum up the accuracies and divide it by k. Then you can get the more justifiable evaluation of model performance. That's the procedure of k-fold cross-validation. Let's talk about its pros and cons. First, we didn't waste any data because the whole dataset is used for both training and testing. On the contrary, for traditional validation, the testing set is never used in the training phase, so we kind of waste a certain amount of data. Further, we don't need to worry about whether a specific split is appropriate, but this advantage is under the assumption that the data is balanced. The second advantage is that the estimation of model performance has low bias. This is sort of the common advantage of all the cross-validation methods because that's the benefit of resampling. The bias is reduced when the data is randomly resampling. That's the 2 main advantages of k-fold cross-validation, but it also has some problems. First, it's not suitable for imbalanced dataset. By imbalance, we mean the class distribution in the data is skewed. One class may have much more data points than the others. Therefore, even if we do the resampling multiple times, we may still generate training set that only contains data from one class. In this way, the model will always classify the data to a single class. And that's not what we want, right? So that's a problem. Another problem is that k-fold cross-validation is not suitable for time series data, since samples are selected in random order. Time series data has ordering from long time ago to present day, but a random resampling doesn't take time into account. Therefore, we disturb the structure of data by resampling, so it's not really working for time series data. That's the basic idea of k-fold cross-validation. Let's stop here for today. Thank you for watching my video and see you soon.